In this video, we're going to be talking about some important physics terms, and we're going to be focusing on the differences and similarities between speed and velocity. So first of all, if you're taking a look at these two different quantities, we have two terms that you want to be familiar with. We have a scalar and a vector. A scalar is just something that has a magnitude, and a vector is something that has a magnitude and a direction. Now, although the definition of magnitude isn't a number value, in physics, typically, if you're referring to a magnitude, you're basically asking how much of something there is. For example, the magnitude of a velocity or a magnitude of a distance, then you're basically giving a number value. And then with the vector, you would be giving that magnitude as a number value. And in addition, you'll be adding some sort of direction as well, which in physics is very commonly noted with a positive or negative sign. So they are very similar to one another. Vector just has a little bit more detail there, including the direction. Now, between speed, distance, velocity, and displacement, there are some subtle differences that will change your approach to different questions. For example, speed is a scalar value, and because it is a scalar, it can only be positive because it's just simply showing the magnitude of how much distance they cover per a certain time interval. So it is solved by distance divided by time. All three of these are scalars, so all three of these must be positive numbers. Now, the definition of distance is something along the lines of the total length traveled. And the total length traveled, basically what I mean by that is something like an odometer on a car or a pedometer for a person, where it's basically just tracking how much you're moving. It doesn't matter if you're going left, right, up or down, forward or backwards. You're basically continuing to increase that total distance. Now, for velocity, we are talking about things that are vectors now. So velocity, oops, I almost wrote vector. So velocity is a vector, so it can be positive or negative to show the direction. And this is solved by the delta x over time. So time is just a scalar that cannot be negative, but displacement is also a vector, which means it can be positive or negative. And the way that you find that is you basically just take your final position minus your initial position in order to get that delta x value. So if you come up with a negative delta x, that means the person or thing has just scooted back in the opposite direction a certain amount. So they're both very similar. They're giving you some kind of rate that's in meters per second. But like I said, there are some subtle differences there that can make some major changes in your calculations. So for example, if you are taking a look at this problem where a person goes forward 20 meters in 5 seconds, and then they slide backwards to the 5-meter mark in 3 seconds and to the 10-meter mark in 2 seconds, the way you would solve for distance and displacement is going to be a little bit different. So let's go ahead and clear a little bit of room first. So with speed, what you're going to do is this. If you want to find the speed, the average speed for the entire trip, it would look something like this. You went 20 meters for the first portion. Then you went an additional 15 meters, because if you went from 20 all the way back to 5, that's 15. And then for the last chunk, if you went from 5 to 10, you're throwing an additional 5 right there. So what you would do is you'd go ahead and add those up. 20 plus 15 plus 5 equals 40 meters. That's the total distance. So that's just the magnitude of how much the person has moved, or the total length traveled. And then we have 5 seconds plus 3 seconds plus 2 seconds, 5 plus 3 plus 2, and that gives us 10 seconds. Okay, so our average speed for the entire trip would be 4 meters per second. Now, if you were to do the same thing for velocity, it's much more simplified actually. You would just take a look at the final position and then subtract the initial position. The final position is right over here, and the initial position is right over here. So this one is going to be simplified quite a bit. The final position is at 10, the initial position is at 0, 10 minus 0, and then over the 10 seconds for the entire trip. So then you just end up with 1 meter per second for the average velocity of the entire trip. Okay, now why are those values so different? One of them is a good gauge of how fast the person is actually moving. That would be the 4 meters per second. So if you are actually seeing the person in motion, they're running on average about 4 meters per second the entire time. Okay, so that's how much length they're covering per second. Now, if you want a better gauge of where the person is going to end up, then this number is going to be a little bit better, because if you were to move 1 meter per second for a total of 10 seconds, then you would end up at 10, right? So that would be a better gauge of showing you where you're going to end up for your final position. Now, if you were to graph those two, it would look something like this. All right, so that's about the best I could do. So if you were to graph it, it would look something like this. So you may be reading some kind of position versus time graph, or you might be reading a word problem or a diagram such as this one over here. So if you're looking at something like this, um, you could have tracked the total distance by seeing how much it rises or falls vertically. And if you track that, then you could have seen that it moved 20 meters, then it moved 15 meters backwards, and then additional 5 meters forward. Okay, and then you could have used similar methods for the final initial position. Here's the final position at 10, and then here's the initial position at 0. Okay, one more graphical trick that you could possibly use is this right here. If you connect the beginning to the end point over there, that is going to give you your average velocity. Okay, if you find the slope of that line, which is basically it rises 10 and then runs 10 over, so 10 over 10 would also give you that 1 meter per second. So on average, if you connect that beginning and that ending point, that is also going to give you your average velocity. So you can use that trick as well, just depending on what you're presented in order to do your problem solving. So to sum things up, when you're talking about speed, distance, and time, those are all scalars. Those are all positive numbers 100% of the time by definition. When you find your distance, you're basically just racking up your total amount that you move. You will always keep on making that number larger and larger and making that a greater positive number. With velocity, because you're including some directions, you are going to have some positive and negative numbers besides for time, but your delta x and your velocity are going to be vectors. So both of those can be negative, showing you the direction, whether it's forward or backwards or up and down, something to that degree. Um, but yeah, so I hope those ideas and methods were helpful to you. Thank you for watching and listening.